702 and Cape Talk.
The Naked Scientist.
You can give us a call, any question about science, and you can put it to Chris, the Naked Scientist. Tweet us a question. Just make sure that you tag at Naked Scientists with an S. Chris, good morning.
Morning, Yubi. How are you?
I'm very well, thank you, sir. This is a really interesting science story. Some fascinating developments at Northwestern University that may get rid of all the wiring around us.
This is a story all about making it easier for premature babies to be looked after, cuddled, and have close contact, and to minimise the amount of wiring that they're subjected to. It came out in the previous edition of the journal Science. The work has been pioneered by a guy called John Rogers and a paediatrician called Amy Paller. And they were very conscious of the fact that when you have premature babies, some as young as 24, 25 weeks, A, they're absolutely tiny, B, their skin is extremely delicate, but C, they need enormous amounts of very intrusive, very invasive monitoring to make sure that they're not going off and getting unwell, or to keep them alive. They need ventilating. They need very close supervision. And all of this involves enormous amounts of wiring, monitoring, things stuck on the skin that's paper thin and will tear and bruise incredibly easily. This means that it's very hard to handle these infants and to bring them out of their incubators and give them the cuddles and human contact that they also need. And so what John Rogers is a pioneer of devices which are thin film, microelectronic devices, non-invasive monitoring and so on. What he's done is to produce with his team these patches which they look like a piece of cellophane that are completely flexible, almost like a sticking plaster, with microelectronics written into them. And they stick onto the baby's skin. You need just two of them in two different locations. And the microelectronics pick up energy from a coil, which is placed underneath the mattress of the baby and beams the energy in wirelessly. It's picked up by the device on the skin. This powers the electronics, which then makes non-invasive measurements of things like temperature, like the oxygen level of the blood, like the pulse rate, collects this information and then wirelessly beams the data off to a central station, for instance the nurse's station, where the medical team can keep an eye on how the baby's doing. And the great virtue of this is it means there aren't all these wires taped all over the place. It's much easier to clean the babies and to hold them, handle them, and give them that close personal contact that they also need for their healthy development. And so this is being held as a big breakthrough and a revolution in actually how we do this in neonatal intensive care.
What about big babies like myself?
Well, big babies like you could have one of these skin patches too, because John Rogers has a long track record of developing these sorts of implants and stickers. He's also made a tattoo in the past, which if you're partial to a tattoo, you can tattoo onto the skin either temporarily or possibly permanently similar microelectronic devices that can make measurements, collect data, and then enable you to interact with the world around you. So actually, you could go and have this too, Yubi.
Karen, good morning.
I have a question for you, Chris. If a horse is in a paddock and there's a lightning storm and he's got metal shoes on, why does he not get struck? Why is there no danger for the horse?
Good morning, Karen. The answer to this is that the metal on the feet of the horse probably doesn't make a huge amount of difference. What tends to attract lightning is if you distort or deform the electric field between the base of the cloud and the ground and encourage the air to ionize and form a path to Earth at that point. Now, the things that deform and distort the electric field the best are tall, sharp, pointy objects, people's umbrellas, trees, the spires of churches and other tall buildings and so on. So if you're a big horse standing in a very flat paddock, you are the tallest object and you will be distorting the electric field a bit. And because a horse's body is full of nice salty water, which is a much better conductor than the air, the horse will potentially provide a nice route to ground for some of that energy. Now, there is one other thing that might happen to the horse, which is that because horses have very long bodies, the front half of the horse and the back half of the horse are a considerable distance away from each other. And if the lightning were to not hit the horse, but to hit the ground near the horse, the potential or the voltage of the ground where it gets hit would be very high, and the electricity would seep away, going away from the point of contact, leaching out into the ground. So if the horse had one end of its body pointing towards where the lightning hit the ground and the opposite end of the animal pointing away, there's therefore the potential, excuse the pun, for electricity to go into the front end or back end of the animal, through the animal's body and out the other end. And this is why some farm animals and big animals like horses and others are sometimes found dead in fields, potentially with burns, because lightning has hit the ground, and as well as flowing across the ground surface, the lightning has gone up the animal's legs, through its body and out the other end. And so that can happen too.
Let's go to Milnerton in Cape Town. Garen, what is your question?
Hi, good day. Yeah, I would like to know the DNA coding system is a sophisticated language system. How did it arise without it being created?
Thank you, Garen. I'm chuckling partly, Chris, because I enjoy listening to you answering the questions and shut up during this 30 minutes. But in the background to my question a week or two back to you, when I asked a follow-up question from a peanut gallery, why we ascribe almost human features to certain processes for purposes of teaching popular science. You said it's because people can often learn when you relate to something they already understand. And often I thought that the reason why people struggle to understand the blind element of the evolutionary processes is because sometimes for purposes of popular science, it's described as if there is intelligent design behind it.
Yeah, I mean, this is a very difficult thing to get your head around at the best of times. But winding the clock back to where life began, we think that happened about 3.9 billion years ago. And that's interesting in and of itself because the planet is only about 4.5 billion years old. And what that tells us is that the processes which we regard as fundamental to life and the chemistry, they got started really promptly after the Earth formed and have been running ever since. How do we know that? Because if we look at life on Earth and we know how fast life evolves, and we know that the DNA code that's running in my body is the same DNA code that's running in E. coli, a bacterium which I last shared an ancestor with, if you wind the evolutionary clock back at the rate at which things evolve, was billions of years ago. And the fact that we have the same identical genetic code shows that we must share an ancestor. We must have come from a common origin, because there's no way that the same complexity and the same intricacies would have evolved exactly identically twice. I can take a gene out of my body and put it into E. coli, the bacterium that lives in my intestine, and that gene will drive exactly the same product because the decoding, the DNA machinery in the bacterium can understand that genetic message in just the same way that my body does, and vice versa, pretty much. Now, in terms of how life actually got started, obviously, we don't know, because unlike fossils, which are impressions in rock of what had once been alive, it's very difficult to find traces of that early life preserved. But what we therefore have to do is infer the existence of these things in the way that I just have, using examples such as how DNA sequences have evolved and how related things are. But what we can do is to begin to rebuild models of how this might have happened all those billions of years ago. And the current favoured hypothesis is something called an RNA world hypothesis. And there is a molecule which is a relative of DNA, which is called RNA. And unlike DNA, which is two strands of information, one the mirror image of the other, with the two tangled round each other, RNA is just a single strand of information, but chemically it's really similar. And it can do many of the same things that DNA can. And in fact, we use it in every cell in our body to convey instructions, the recipes from our DNA, into the cell where it turns that DNA message into useful chemicals that our cells can do things with. They're called proteins. But the interesting thing about this RNA is that as well as carrying genetic information, it can wind itself up into very interesting three-dimensional shapes and structures. And that means it can not just store information, but it can also work as a machine. And scientists have now shown that these micro machines can drive various chemical reactions. They can catalyze reactions. And so our current theory about how this got started in the first place is that some of these molecules randomly formed, they adopted interesting shapes by chance, because if you do enough things enough times, this is the monkeys and the typewriters analogy. There's an analogy everyone can identify with, Eusebius. Then what you end up with is, by chance, a bunch of molecules that happen to have the right shape and the right configuration to do the right chemistry to make copies of themselves. And if you've got huge amounts of raw materials and you've got something that can then start using them and organising them in some way, it's going to become a positive feedback loop and make loads of itself. And as it does so, because it's storing genetic information, it's programming its own existence, every time it changes or makes a genetic mistake or a tweak, it has the potential to improve itself. And this led then to a sort of runaway evolution process where we slowly fashioned something that became very efficient at doing that, and then we get to today, 4 billion years later. So there in a nutshell is 4 billion years of evolution.
Paul in Durbanville, good morning to you. What question have you got for Chris?
Yeah, strange enough, it's a wireless question. I don't want any tattoos, but I would like to become wireless, and I just want to know if we're ever going to get to the point where high current, as in our household fridges and stoves, will be wireless from a distribution board in the garage, and we will no longer require conduits and switches and things like that. Is it possible that we can actually be driving our electric car down the road and go past charge boxes and automatically charge without plugging in?
Oh, wouldn't that be wonderful, Paul?
Will it ever happen?
I'd like to think so. But, I mean, initially, if you'd said that, say, 20 years ago, people would have said you were mad. But the reality is that we have invented much better electronics these days where the efficiency of these devices is extraordinarily good. So, for instance, the electric light bulb, which is illuminating the rooms that we're in the evening and the offices we work in, historically, they were only about 15 if that percent efficient. That meant that 85% of the energy we were pumping into them was just being turned into light we couldn't see. It was heat, infrared. LEDs are incredibly efficient in comparison. And so the amount of energy it takes to drive a light source, which is really bright, has now become much lower. And this means we're into the realms where previously it was just completely impossible to transmit wirelessly the energy density and energy that we needed to run decent gadgets. These days, it's becoming much more tractable. So I wouldn't rule this out. I think that is certainly true. And people are even inventing devices that are capable of extracting energy from their environment and being completely autonomous. About 10 years ago, I had a conversation with Mike Muller, who's one of the technology officers, I think is the chief technology officer for the company ARM. And ARM designed the microchip architecture that's running in about 99.9% of mobile devices. So they know a thing or two about how you make chips and how you make circuits and operating systems that are very low energy. And he told me that one of the things that they were interested in and they've been investigating were tiny devices that use energy of molecules slamming into the surface. So if you have one of these things, if you had a little monitor on a wall, for example, you could extract energy from air molecules buffeting that surface, and you can extract enough energy to make one of these things work. And it would be obviously a tiny amount of energy it was extracting and a tiny amount of energy it was using, but it just goes to show the realms of what might be possible in future. A car, though, is a very different beast. The amount of energy it takes to move a car along with you inside it and push all the air out of the way that you're pushing out of the way to move your vehicle along, that's a huge energy spend. And these cars have really big batteries and they produce very high currents to drive the motors in the cars. So I think for now, it's very much a pipe dream that we're going to be driving down the road and your car's going to be wirelessly charged up. I think something else will have to happen. There'll have to be some other kind of technological revolution before that happens. But certainly microelectronics and beaming energy into them wirelessly, that's already here, and that's only going to get more and more prominent in our daily lives.
Mark, good morning. Welcome to the show.
Thank you. I need to find out how much calcium, if any, remains when we mix our milk with our tea.
Hello, Mark.
Interesting question.
Yeah. Well, one of the richest dietary sources of calcium in the average person's daily intake is milk. You really have to try hard to beat milk for calcium. It's an excellent source of calcium. Now, if there's something in something to start with, when you put that thing into something else that you consume, the thing that was there to start with can't mysteriously and magically disappear. It remains there. So there will therefore be calcium in your tea. That said, there are other chemicals in the foods we eat that can bind onto calcium and they can remove the calcium from your ability to absorb it. This can also happen with other micronutrients and vitamins. And some dietary components, for instance, phytic acid, which is in the flour that's used to make certain, say, chapatis and other Indian cuisines, this can soak up the calcium and put it into a form that you can't access. So it depends on what sort of tea it is, how strong the tea is, and what else is in the tea and what else is in your diet when you consume the tea and lunch or dinner, because those things may have chemicals that bind up calcium. But just drinking milk for milk's sake, as long as you're not lactose intolerant, and that's quite common too, that's a brilliant source of calcium, and we should probably all get more calcium. Many of us don't get enough.
Let's go to Plumstead. Miriam, good morning. Welcome to the show.
Thank you. Good morning. My granddaughter has an obsession with stuff called glue. It's a very gooey stuff, and now the latest incarnation has, it starts off as pink. If you hold it in your hand and it gets warm, it goes pink. And if you leave it to cool off, for instance, in the fridge, it goes purple. So she is very amazed by this change in color and temperature, and she wants to know what does it. And we've had all kinds of conversations. So she told me that it was a chemical. She said, Granny, it must be a chemical, and it must have sensors in it. We decided to ask the science teacher who didn't know.
Thanks for that, Granny Miriam.
So hang on, you said, Miriam, the science teacher didn't know.
No, it wasn't the science teacher. It was a lady who does an extramural with the kids called Curious Cubs.
Oh, we'll let her off
they do
then.
experiments with bicarb and stuff like that. Yeah,
we'll let her off. This is quite a common phenomenon, and the way this works is that the reason something has colour at all is because the molecules in the thing that's got the colour are absorbing white light, and white light is made of all of the colours of the rainbow, and they are not absorbing the colour that the object is. So if I have something that's, say, red, when I shine sunlight on it, the reason it looks red is because the molecules in the fabric are absorbing all of the colours in the white light except red, which is being reflected back at you, so you see red. If it looks blue, it's absorbing all of the colours in the rainbow except blue, which it's reflecting back at you, and that's why it looks blue. Now, for something to change colour from, say, I'm just making this up, but say it's red. For it to change colour from red to blue, that means the molecules have to stop reflecting red, absorb red, and instead stop absorbing blue and reflect blue at you. So how does that happen? Well, there are various molecules which, when you warm them up and give heat energy to them, they change their configuration or their structure in 3 dimensions. And that change means that they actually, because the nature of the chemical is different, it will interact with light of a different wavelength. And blue light are much smaller waves, closer together, than red light, which are further apart, have a longer wavelength. And if you reconfigure your molecules due to high temperature, then the molecules are the right shape with the electrons in the right distribution that they'll better soak up light of one wavelength compared to another. And then when you cool it down again, the molecules reconfigure themselves, change their shape again, and they go back to how they were to start with. So it's all to do with the shape of the molecules relative to the size of the waves of light which are hitting them, and therefore the colour of light that gets re-radiated back to you.
Fascinating. Shakir, good morning. Welcome to the show.
Good morning. Good morning.
Go ahead.
I have a question. I would like to know if secondhand vape from e-cigarettes are just as harmful as regular secondhand smoke from cigarettes.
Thanks for that question. I've been wondering, besides being irritating, how harmful are they, Chris?
Well, the answer is that e-cigarettes, compared with a traditional cigarette or a day out in Joburg in the heavy traffic, which is equally bad as smoking a cigarette, actually. In fact, any city. London's terrible. Compared with traditional cigarettes and air pollution, e-cigarettes are probably less harmful for you. That's not to say they do no harm, because scientists have shown various changes in the airways in response to vaping. There are various chemicals in the vape that are irritant to your airways. They also make the cells stickier, so they can encourage microorganisms to stick onto the airways, and this can make you more prone to infections under certain circumstances. But second-hand smoke is still smoke. And therefore, although the concentration of smoke going into you is going to be lower than it will to the person who's doing the smoking or vaping, you are still breathing those particles in. Therefore, there is still the potential, if there is an opportunity for harm to happen to you, it will just happen to you a bit less. It's a bit like if you're a passive smoker, it doesn't mean that you're at no risk of lung cancer because you're not the one doing the smoking. You are doing the smoking, you're just smoking a bit less, effectively, than the person who's holding the cigarette or doing the vaping.
Andrew, good morning.
Hello, Sirius. Dr. Chris, in the 70s, NASA sent out the Pioneers and Voyager spacecraft into interstellar space. Are they still in contact with them?
Hello, Andrew. The answer is yes, they are. And both Voyager 1 and Voyager 2 have left the solar system, but they do remain. Certainly, I was talking to someone who's just released a concept album, a music album, all about Voyager, and we looked up all the stats for Voyager, and it's still in contact with NASA. Many of the instruments have now been shut down because the amount of power available from the power unit in Voyager is quite low. It's a radiogenic source, so it's got I think it's a big chunk of plutonium or polonium in there that's producing radiation that's being used to drive thermoelectric generators. But yes, Voyager is still active. It's so far away that the radio signals it's sending back are taking a day, 24 hours at least, to get back to the Earth now. So it's not actually in our solar system anymore. It's gone through something called the heliopause, where the radiation pressure from our sun meets equivalent incoming radiation from intergalactic space, and it's passed through that, and it's now out beyond our solar system, and it's heading for the next galaxy. And in 60,000 years or so, I think that's when it's due to get there. So long way to go.
Wow. Let's take a question from Twitter, just to make sure we also spread some love on social media. Marcella says, with, I think it looks like an emoticon indicating half his tongue in cheek, but I'm still going to ask you the question. Why, can you ask Chris Eusebius, why do mountain goats feel seemingly compelled to climb up sheer rock faces to dizzy heights? And it seems impractical, uncomfortable, and downright dangerous.
Well, some of them do succumb, of course. I mean, we've all seen this where you see a dead mountain goat. They do fall occasionally, but they're very agile. And the reason they do it is because they have evolved to do it. If they have the ability to climb up these mountains and to remain sure-footed and not feel dizzy and get vertigo and fall down the mountain, they can access food which other animals wouldn't be able to. So they're going to get better nourished. They're also, if they're clinging to a rock face that the predators can't get to so easily, not going to get eaten so often. So nature has endowed them, and evolution has endowed them with the ability to do that, and it's made them successful. If they weren't successful at doing that and they did fall off the mountain, evolution would quite quickly dispense with them, wouldn't it? And they'd be lost from the gene pool, and goats that were more sure-footed and didn't fall off the mountain would replace them.
And that would be a blind evolutionary process, not because there's a grand designer. I had to sneak that in.
Full circle.
Chris, indeed, a stunning half an hour. So many more questions. We don't have enough time, but we'll do it again next week. Thank you for sharing your knowledge with us.
Thanks, everybody. See you soon.